Imagine Earth before dinosaurs, a world without giant footprints or fearsome roars. This was a time when life was just beginning. Tiny organisms swam in vast oceans, volcanoes erupted, spewing lava and ash. This is the story of our planet's earliest days, long before the dinosaurs ruled. Join us on a journey through time. Let's explore a world stranger than fiction. Our journey begins 4.6 billion years ago, in the vast expanse of the early solar system. Earth forms from a swirling cloud of dust and gas. Gravity pulls everything together, creating a new world from the remnants of ancient stars. The young planet is a ball of molten rock, a seething mass of fiery lava and intense heat. Asteroids and comets constantly bombard its surface, delivering both destruction and essential elements. This period is called the Hadean Eon, named after Hades, the ancient Greek god of the underworld. It was a hellish time, not suitable for life as we know it. Volcanic eruptions were frequent, and the atmosphere was thick with toxic gases. Gradually, Earth begins to cool. The relentless volcanic activity starts to subside. The molten rock solidifies into a crust, forming the first solid surface of our planet. Water vapor condenses and falls as rain, creating torrential downpours that last for millions of years. Oceans begin to form, covering the planet's surface. This is the Archean Eon, a time when the Earth starts to stabilize. It marks the beginning of a more hospitable Earth, setting the stage for the emergence of life. The once hostile environment slowly transforms into a cradle for future life forms. About 3.8 billion years ago, something extraordinary happens. The first signs of life emerge in the primordial oceans. These early life forms are simple single-celled organisms. They are called prokaryotes. They survive without oxygen, relying on chemicals for energy. These tiny organisms are the ancestors of all life on Earth. These early organisms were incredibly resilient. They withstood intense heat and volcanic activity. Life had taken hold on our young planet. It would forever change the course of Earth's history. For billions of years, life remained microscopic. Then, around 2.4 billion years ago, a dramatic shift occurred. A new type of organism evolved, cyanobacteria. These bacteria could perform photosynthesis. They use sunlight to create energy, releasing oxygen as a byproduct. This event, called the Great Oxidation Event, transformed Earth's atmosphere. Oxygen was toxic to many early life forms. A mass extinction event followed. However, this event paved the way for new oxygen-breathing organisms to evolve. It was a turning point in the history of life on Earth. Section 5, the Cambrian Explosion. Life took a giant leap forward during the Cambrian period, which began about 540 million years ago. This era is renowned for its remarkable burst of evolutionary activity. In an event known as the Cambrian Explosion, life diversified rapidly. This period saw the emergence of a wide variety of complex organisms, many of which were unlike anything seen before. A dazzling array of new creatures appeared in the oceans. These included trilobites, jellyfish, worms, and many other fascinating forms of life. The ocean floors were teeming with activity as these new species interacted in complex ecosystems. Among these were the early ancestors of modern-day animals. Primitive fish began to make their appearance, setting the stage for future evolutionary developments. This period marks the beginning of the Paleozoic era, the era of ancient life. It was a time of significant change and adaptation as life forms began to explore new ecological niches. The Cambrian Explosion is considered one of the most significant events in the history of life. It represents a pivotal moment when the foundations for future biodiversity were laid. It set the stage for the evolution of all complex life forms. The diversity that emerged during this time provided the building blocks for the vast array of species we see today. The Cambrian Explosion was not just a moment in time, but a crucial chapter in the story of life on Earth. Section 6. Life gets more complex. Following the Cambrian Explosion, life continued to evolve and diversify. Creatures developed new adaptations, such as shells and skeletons. Some creatures, like the bizarre Opabinia with its 5 eyes, showcase the incredible experimentation of early evolution. These new adaptations allowed animals to move and hunt in different ways. Predators evolved, leading to an evolutionary arms race. This period saw the development of increasingly complex ecosystems. Section 7. Ediacaran Enigma. Before the Cambrian Explosion, during the late Ediacaran period, another set of mysterious organisms thrived. These soft-bodied creatures, unlike anything alive today, left behind enigmatic fossils. Their relationship to later life forms is still debated. Some scientists believe they represent a completely different experiment in multicellular life. These fossils provide a glimpse into a truly alien world. They remind us that life on Earth has taken many strange and wonderful forms throughout its history. Section 8. From sea to land. Life, which had flourished in the oceans for billions of years, began to colonize land. Plants were among the first pioneers, followed by arthropods, the ancestors of insects and spiders. This move to land was a momentous step in evolution. It opened up vast new habitats and resources. It paved the way for the evolution of terrestrial vertebrates, including, eventually, ourselves. Section 9. The Mystery of Extinction. Life's history includes both emergence and loss. Mass extinctions reset evolution, allowing new species to evolve. Section 10. Unlocking Earth's ancient secrets. Studying Earth's pre-dinosaur history is crucial. It provides us with a window into a time long before humans walked the Earth, a time when the planet was a vastly different place. By examining these ancient periods, we can uncover the secrets of how life began and evolved over billions of years. It helps us understand the origins of life itself. The study of ancient microorganisms reveals the earliest forms of life that thrived in primordial oceans. These tiny life forms laid the foundation for the complex ecosystems we see today. By piecing together the fossil record and analyzing ancient rocks, scientists are constantly making new discoveries. Each new fossil, each ancient rock formation tells a story of a world that once was. These discoveries are like pieces of a giant jigsaw puzzle, slowly revealing the grand picture of Earth's history. Each fossil adds another piece to the puzzle of our planet's past. From the tiniest microfossils to the bones of gigantic prehistoric creatures, every find is significant. These fossils help us map out the evolutionary tree, showing us how different species are related and how they adapted to changing environments over millions of years. As we delve deeper into Earth's history, we gain a greater appreciation for the incredible journey that life has taken. The progression from simple single-celled organisms to the diverse array of plants and animals we see today is nothing short of miraculous. We also learn valuable lessons about the interconnectedness of Earth's systems and the importance of protecting the diversity of life on our planet. The history of life on Earth teaches us that all living things are interconnected and that the health of our planet depends on maintaining this delicate balance.